What do the line, the circle, the ellipse, the parabola, and the hyperbola have in common? Mathematics is an abstraction. Its expression, concise, descriptive, and imaginary. Its realm, the mind, birthplace of the finite and the infinite. Imagine a dunce. Remove the dunce. What's left is a cone. Imagine another cone. Invert the second cone and place it on top of the first one. This is a finite mathematical cone. Now, extend the cone into infinity, onward forever and never ending. This is the infinite mathematical cone, the genesis of conic sections. Imagine a plane. It slices the cone along the side, producing a line. Now tilt the plane perpendicular to the axis. We get a circle. Tilt the plane slightly. We have an ellipse. Now tilt the plane so that it is parallel to the sides of the cone, producing a parabola. Set the plane parallel to the cone's axis, producing a hyperbola. Now let's try to reconstruct the conic sections. Obviously, we need to start with a frame of reference. With the use of equations, we can draw graphs. We can draw lines, circles, ellipses, parabolas, and hyperbolas. The graph also helps us to locate the important attributes of a conic. For instance, we can easily find the center and asymptotes of this hyperbola. By varying the parameters of the equation, the graph changes. As the numbers change in this equation for a circle, the cone slice and the graph change accordingly. This is true for the other conic sections also. An interesting case occurs when the plane cuts the endpoints of the two cones. This conic is a point. However, this is considered a trivial case and is seldom mentioned. We can easily show that the various conic sections are related to each other. Hyperbola, line, parabola, ellipse, circle. The first known mention of conics was by the Greek geometer Menaechmus.
Conics.
Years later, a Greek astronomer by the name of Apollonius wrote an extraordinary and lengthy treatise entitled Conic Sections.
Ellipse, parabola, hyperbola.
The names ellipse, parabola, and hyperbola were supplied by Apollonius. The Italian astronomer Galileo Galilei was the first to realize the parabolic nature of the path of a projectile. Johann Kepler's laws of planetary motion, extensive use of conic sections. Newton further developed these ideas in his book Principia. For Newton, the conic section served as the taking off point for his invention of calculus.